In this video, we're going to look at graphing quadratic functions. That'll be our main focus for the graphing for the remainder of the chapter. The first thing is, what is we have to let's define what is a quadratic function. Well, quadratic function is a second degree polynomial function, and its standard form could be written in f of x equals ax squared plus bx plus c. Think of a second degree, so a leading term has the highest power is a 2, and so if I asked you a question, just being able to identify a quadratic function, and I ask you to circle them, this one right here, a would not be, it's a rational function. B is a radical function. C is because of the x squared, and D is not, it's a cubic function because of the x cubed. So the leading term is a second degree function, second degree polynomial function in particular. And so so be able to identify that. You'll see questions like that possibly on the test. Now the next thing is finding a comprehensive graph of a quadratic function that's in standard form. Well, now say it's not in a nice transformational form where I can just graph it quickly by looking at moving it right or left, the original basic graph. Say it's in something like the standard form of f of x equals x squared minus 6x plus 8, and I wanted you to complete the graph. The first thing to identify, does the parabola open up or down? If you just look at a, the leading coefficient is always a. If it's positive, it opens up, guaranteed every time. And so since a is greater than 0, it opens up. What is the vertex? The vertex is actually that either very low spot or very high spot of a parabola. And so it's either the very bottom of the valley or the top of the hill. And so what is the vertex in this? How do I find it? It actually comes from the quadratic formula. If you think about what is the front part of the quadratic formula, if the discriminant was 0, you end up getting negative b over 2a before the plus or minus. So the vertex is actually just going to be negative b over 2a, and then you just once you find that, you just plug that value back into your function to get your output of, so I just call f of negative b over 2a. Now there is also a formula for that to remember if you wanted to, but it's easier to just remember one thing and then you just dump that into the function to get the output value. So think of it in function notation, x f of x. So what is the vertex? Well, if I know how to identify a, b, and c, negative b would be 6 divided by 2 times 1, which is going to be 3. So I get 3 for a value. Then plug that 3 into your function. F of 3 is going to equal 3 squared minus 6 times 3 plus 8, which ends up being negative 1. And so my vertex is that ordered pair 3 comma negative 1. Is the vertex a min or a max? Well, since the parabola opens up, it's definitely a minimum. It's the lowest point of your graph because it's the valley. It'll be the very low spot. Think of the shape of the graph, the parabola, it opens up, so the vertex is that low spot or minimum. That's important if you're looking at application problems and you're trying to find a min or a max. What is the axis of symmetry? So what we're doing is we're finding a comprehensive graph. We're finding all these important things so we can graph it really accurately. So an axis of symmetry is basically just a vertical line, because if you think of the parabola, it's just going to be a vertical line that goes right through the vertex, because everything else will be mirror images on each side. And so it's actually always just going to be x equals negative b over 2a, which is just going to always be x equals the x coordinate of your vertex. What is or are the x-intercepts? Sometimes you'll have 1, none, up to 2 possibly. So if you want to find the x-intercepts, it's where does the parabola cross the x-axis. You just take your function or your y and set it equals 0. So you take the overall equation and say 0 is equal to x squared minus 6x plus 8. Then I would factor and solve. This one factors nicely, and you should end up getting 2 and 4 for your 2 answers. So 2, 0 and 4, 0 would be the 2 x-intercepts. The y-intercept is you just plug in 0 for x. So find f of 0, and f of 0 ends up being 8. When you plug in 0 for both those, you get 8. And so 0, 8, and then now I would plot all of these and graph them, and I usually make my x symmetry just a dashed line. So let's go to Desmos and graph this function. Let me make sure I remember which one. X squared minus 6x plus 8. So let's go to this. Let's go to x squared minus 6x plus 8. So there is our function that we're talking about. And so when I'm graphing this thing, I noticed there's my vertex, 3, -1 to verify. It opens up. There's my x-intercepts, 2 and 1. I like to also, draw on the axis symmetry, just to talk about the x symmetry. I generally, when I draw these, it's a dashed line because it's not really part of the graph. It's just a dashed line, and it's always a vertical line, so you have to say x equals. It's important to say the x equals 3, not just 3. And then you'll notice that why is that x symmetry? Because there's a mirror image of a point directly across from each point. So that's why you could fold the graph and it would line up exactly. And that helps us to graph these things. And then we said the y, let's see, let me zoom out. So we said the y-intercept should be 0, 8, and it is. So we can see that. And then now a cool thing is, once we have that point, it's nice to have the x symmetry because I can count over 1, 2, 3, 4, 5, 6 lines here. So actually, I'm saying over 3. So 1, 2, 3, and then I can actually make another point. It's not coming in exactly because of the way the graph is. But basically, if you would want to do that, you could just count over. I guess I have this in increments of like a half. So if this was like 1, 2, 3, count over 3. So then you go 1, 2, 3, and then make another point, so you can make sure you graph it accurately. And I had it there for a minute, but 6, 8 would be an ordered pair on the graph. And so that's it. And so it's a really nice way to do it comprehensively. Now you do not have to actually, and then you graph this, you do not have to do the next thing that I'm going to show you, but one cool thing to do is to check your graph is, what if you're like, you have lots of time on the test and you're like, okay, I've got the -b over 2a, the vertex stuff down, I know how to graph this, but you want to check to make sure you got it, and you want to maybe check by transformation. You're not going to be required to do this kind of a graph, but it's really neat to see. You could actually complete the square of a standard form of a quadratic and actually write it in a transformable form and show that they're the exact same graph. So if we look at that exact example we just did, and I look at f of x equals x squared minus 6x plus 8, I can actually just complete the square. We take half of b and square it, and then you just add that to both sides. Or just add and subtract it to the same side is the same as adding to both sides, because, but I'm just going to keep it separate and move the plus 8 down a little bit. I just did that so that it's a little easier, so I don't have to subtract the 9 over later. Then you would just factor this, and you end up getting x minus 3 quantity squared minus 1. Now it's in a transformational form, and you can just graph the original x squared graph, and then I would move this right 3 units, down 1, and it would be the graph. So let's just show that they're the same graph. Let's go to, I'm going to just delete that one, I'm going to hit enter, and so let's type in y equals x minus 3, and then we'll square that, and then we'll say minus 1, and it fell right on top of the other graph. It's the exact function. So just two different ways of looking at it. So it's kind of a nice way maybe to check yourself on a test if you wanted to transform it and you're okay with completing the square. Most people don't, and they're, just make sure but that you do know how to graph a comprehensive graph. Though I am going to ask on the test something like this, where I'll have all these types of questions, and I'm going to ask you, okay, what's the vertex? Is it a min or a max? I mean, same kind of thing, and you're going to want to be able to fill that out and then graph a comprehensive graph of the function. So the next thing that we're going to look at then is an application tied to quadratic functions, and then and I'll do that in another video, and then we will look at variation after that.